All right, I'm just going to go through some of the major white blood cells and components of the immune system with you that you should know. So first of all, let me get out a pen here just in case I need to draw. Um, First of all, you need to know that the first line of defense is this right here, which is your skin. So if you didn't have skin, or if you have if you have a cut in your skin, then right away all these different pathogens can get in. So that is very important to have skin. Um, the other thing is the things that do come in, we either call them pathogens or antigens. Pathogens are any live invader that causes disease. So a lot of things can cause diseases, as you've seen in previous videos. Viruses, bacteria, even fungi, certain protists. Um, so anything that invades your body that's alive is called a pathogen. Well, viruses are not considered alive, but um, we would still consider them a type of pathogen. Now, antigens can also go into your body. So it's any type of foreign material, even a sliver could be considered an antigen, or even virus parts or parts of anything. So anything that is in your body that doesn't belong there um, can be considered an antigen. All right. So once you're past the first line of defense, which is your skin, um, what your body has in it, uh, all over the place, are these macrophages. These are huge, gigantic white blood cells, and they are also called guard cells because they're always on duty, always there. They don't need to be activated or anything like that. They're just always there looking for foreign objects to swallow up. And if you've seen the previous videos, they can swallow over 100 different things at the same time, or in one go. So they're large cells that do most of the guarding around the body. So both the skin and the macrophages, they're both part of what we call innate immunity. Innate just means it's built in. So when you're born, or after a while after you're born, when you develop an immune system, because babies don't have a fully developed immune system, then you have all this stuff built in. Or even babies have innate immunity because they have skin and they have macrophages at the very least. And the rest of this doesn't fully develop until later on. But everybody's got innate immunity. It's built in. So the skin and macrophages we call innate. Now the rest of it, all the other cells that you see here, they're all part of what we call adaptive immunity. So these B cells and T cells, they are all adapted. Oh, the light just went off. So what that means is it adapts to whatever invader comes in, and it gets activated over time. So let's say something goes into your body past the first line of defense, which is the skin, um, which is innate immunity. Uh, the macrophages will try to swallow it up, and sometimes that works, sometimes it doesn't. Sometimes it escapes the macrophages, um, or sometimes they get swallowed up by the macrophages, and then the macrophages signal other cells to come in. So the next part that you should be aware of is these helper T cells. So you can see some helper T cells that I've drawn here. So these helper T cells are designed to get a signal from the macrophages, or from cells after the macrophages, and they basically go to the plasma B cells that you see here and tell them to start reproducing. And they reproduce because plasma B cells have these weapons called antibodies. So they launch these antibodies, and you can see them attacking here like missiles. Basically, these antibodies attach to the surface of bacteria or viruses, and break them down, or they can also act as tags so that macrophages can come along and go, hey, you're tagged, and then start eating them up. Or killer T cells can come in and go, oh, look at these tagged foreign objects, let's destroy them. So helper T cells are very important because they go and they're like messengers. Once they sense that there's something not quite right or something that doesn't belong in the body, they will go and activate the plasma B cells. Plasma B cells start reproducing and then start releasing all these antibodies that do a lot of harm to these foreign invaders. And as a result, either the antibodies kill the pathogen, or other cells come along, like killer T cells that you see over here, and macrophages that come and see that those are tagged with antibodies and then come and destroy them. So antibodies attract macrophages and killer cells. Okay? So plasma B cells are very important. We need those antibodies. We need those weapons. And on multiple levels, they really do a job on these foreign invaders. So those are the main players in the white blood cell that I want you to know. At the end of it all, because your body, goes through this process where it's attacking all these things, and sometimes you will detect that because of swelling or redness, and that's actually your immune system cells, white blood cells, going into that area and battling. So you're watching a war going on. And then after that's done, we don't need all these white blood cells hanging around anymore. So they destroy themselves. Otherwise, you would have swelling and redness all the time, right? And we wouldn't want that. So once it's finished, once the pathogen or antigen has been taken care of, they destroy themselves. But they do leave behind these memory B and T cells. So we've got memory plasma B cells and memory helper T cells ready for next time. So this is very important. This is the cool thing about adaptive immunity. So not only do we have innate immunity that's built in, but we have adaptive immunity that are specialized for that specific pathogen or antigen that has come into your body. So your body can be prepared for exactly how it destroyed that pathogen the first time, because there are some B and T cells left behind that can produce the same antibodies and have the same response. Which brings us to what vaccines are. So vaccines are basically trying to get your body to go through all of this response, but in a way that's not harmful to you. So doctors can inject you with a virus that is not alive, or a virus that is not active but alive. And what that does is it makes your body react, but not like fully react, react in a way that produces some memory B and T cells. The virus will not replicate and invade your body like the normal one would, but at least it gets your body ready for when those live viruses come in. So there's a group of people who get together every year, just before flu season, and they decide which flu is being transmitted using statistics and some calculations and looking at data, and then they decide what vaccine to put out there for the flu. I suspect the same thing eventually will happen with the SARS-CoV-2 virus. When we find a vaccine, they will have to decide how to distribute that. So it's injecting you with, a vaccine is injecting you with part of the virus, or nowadays you can even inject something called RNA, which makes the proteins of the virus, gets your body to make the proteins of the virus. basically to get this immune response without having a virus replicate through your body, but getting their immune response, which produces the memory B and T cells, which then is stored in your body and ready for the actual virus to come in. And once the actual virus comes in, your body attacks it right away and knows exactly what to do. Then it gets rid of the virus or bacteria or whatever pathogen sometimes before you even feel any symptoms. So that's the beauty of a vaccine. So a vaccine is preventative, right? If you already have a disease caused by a virus or bacterium, there's no use putting a vaccine in your body because you're already going through it. So vaccines are preventative. Antibiotics are not related to vaccines. Antibiotics are drugs that you take after you have a bacteria enter your body. So it's not for viruses at all. It's only for bacteria. Okay, so keep that in mind. If you have a flu or cold or COVID-19, an antibiotic won't do anything. You're just wasting the antibiotic, and even worse, you're killing off some of the helpful bacteria that's in your body. So antibiotics are only used in drug form, so in terms of a pill or an ointment, in order to kill bacteria. So the problem with antibiotics is that sometimes people take them too much. And when you take them too much, you expose the bacteria, even bad bacteria that are harmful to you, you expose them to too many antibiotics and they start mutating. And if you don't kill off the ones that have mutated, well, then you've got eventually a superbug. So a superbug then is mutated to the extent where no antibiotic can kill it. So this is a major problem. So you never want to wash your hands with something that has antibiotics in it. You don't want to overtake antibiotics. Doctors should not be prescribing antibiotics for colds, right? Because if you overuse it, then the bacteria will learn from that drug and mutate themselves so that the next generation are immune to those drugs. So that's pretty much all you need to know about immunology. You can always go back and look at these different things and go through the process again. If you have any questions, please email me, and we can also meet on Google Meet. Take care.